data flow diagram. Here we are going to learn a data flow diagram. So as we learned in a software modeling, software lifecycle model, requirement analysis, design and construction, integration, testing, installation and maintenance. These are the lifecycle model of software. Okay. So while analyzing requirement, we need to use a data model. Okay, so data flow diagram is used. The data flow diagram is required for analyzing the data from the end user. So this is the data, and the data analyzing done with the diagram. Okay. So data flow diagram analyze data or the requirement from the end user. The software developer creates a particular diagram, which is called as a data flow diagram. It can be a traditional visual representation of information which flows within a system. A clear data flow diagram draw the right amount of system requirement graphically. Okay, data flow diagram can be done manually, automated, or both. Software developer create a particular diagram, that is data flow diagram. Okay. The clear data flow diagram can draw system requirement graphically. Whatever requirement we gain from the end user, it should be drawn with the use of data flow diagram. The data flow diagram shows how data enters in the system, whatever changes made with that information, and where it's stored, and how the data leaves the system. The objective of data flow diagram is to show the scope and boundaries of the system as a whole. It may be used as a communication tool between system analyst and any person who plays part in the order that acts as a starting point of redesigning the system. A DFD is also called as a data flow graph or a bubble chart. The main result of structured analysis is a series of data flow diagrams. There are 4 types of data entities are distinguished in this diagram. Okay. So first entity is external entity. First entity is external entity. External entities are source or destination of the transaction. Okay. External entities can be a people or an organization that sends or receives the particular data. These entities are located outside the domain consideration in a data flow diagram. Means external entities located in the outside of the data flow diagram. External entities are indicated as a square. Okay. Processes transform. Second is a processes transform data. Processes are denoted by circle. A process transforms incoming data flow into a outgoing data flow. Whatever processes is done between entities or data stores or data flows are denoted in a circle. Data flows. The data flows between processes, external entities, and data stores. Whatever data flows between a particular entities, like a process is doing, or any entity is storing any kind of data. So these all the flows are described in the data flows. Data flows indicated by an arrow. Data flows are a path along which data structure travels. Label the arrow with the name of the data that moves it. We can label these arrows with the name that moves the data. Means what kind of data is flowing, what kind of data is moving from one entity to process or one entity to another entity or another process, whatever, we can label these arrows. Last one is a data store. A data store represents that data used by system like DBMS, text file, etc. are the data stores. These data stores lie between two different processes. Whatever process is happening, it needs some data which stored in these data stores, and it is indicated by two parallel lines. So for developing the data flow diagram or DFD, we are having three levels of data flow diagrams. First one is a level 0. Level 0 data flow diagram can be called as a context level. So the context level identifies external entities and related inputs and outputs. It is the system designer make a context level DFD or level 0 DFD, which shows communication among the system and the system environment. It just shows the communication between two different entities or two related inputs and outputs. This can be a level 0 data flow diagram. Here, passenger and admin are two different kind of external entities. This is input entity and this is output entity. Okay. This is a sender, this is a receiver, this is a receiver, this can be a receiver and this can be a sender also. So passenger and admin is the external entities. And railway reservation is a process done between these two entities. So what happens here, a passenger can reserve a ticket which follows the process railway reservation, and the railway reservation gives this ticket reservation information to the admin, or the passenger can cancel the reservation. What happens with this railway reservation process? This process transform that cancellation process by railway reservation to the admin by cancelling info. Likewise, two different kind of entities can be doing a single process, and this is a data flows, and the cancellation reservation ticket information is labeled to this data flow. Next one is level 1 DFD. Level 1 data flow diagram is the context diagram. In level 1 data flow diagram, the context diagram is decomposed into multiple processes. Level 1 diagram is having overview of full system. It gives the full system. Identifies data stores that are used by the major processes. The large number of processes or high level processes which cannot be done in level 0 or context level data flow diagram are done in the level 1 data flow diagram. Level 1 data flow diagram are divided into sub processes for level 0 DFT. Okay. This is the level 1 data flow diagram. A passenger is an entity. Reservation storage is also an entity. Down storage is a data store. Up storage is a data store. Okay, and reservation is a process. A passenger can do a reservation process with generator ticket generation process. This is also a process, or it can be reported to admin. anything happens with this reservation process, which will be reported to the admin. Okay. Or a passenger can make an inquiry about reservation process. So inquiry is also a process, and this process is having these data stores. Inquiry can be down storage, inquiry can be up storage. This inquiry can be taken the data from these data stores. It will be requested to the data, to both data, and the result will be or output will be given to this inquiry process. Okay, and inquiry process gives to the reservation process and ticket will be generated. Or passenger can inquire about reservation. Whatever reservations are stored in the reservation system will be given to the passenger. This is the level 1 DFT. It shows the detailed information, or we can say full overview of the processes. Next one is a level 2 data flow diagram. Level 2 data flow diagram expanded in more detail. Sorry, level 1 expanded in more detail for this level 2 data flow diagram. Level 2 data flow diagram goes one step deeper into parts of level 1 data flow diagram. It can be used to plan or record the specific or necessary details about the system functionalities. This is the level 2 data flow diagram. It is having all the necessary details, all the necessary information about the passenger reservation process, report, ticket generation, cancellation, everything. A detailed information is given in this level 2 data flow diagram. The next point is entity relationship diagram. Entity relationship diagram can be called as a ERD. ER modeling is a data modeling method to produce conceptual data model of an information system. Diagrams created using this ER modeling methods are called as entity relationship diagram or ER diagram or ERDS. Okay, whatever diagram we create using this ER modeling is called as a ER diagram. And ER modeling is used to produce a conceptual data model of the information system, which gives a detailed concept, which clears our detailed concepts. Okay. The database analysis gains a better understanding of the data to be contained in the database through the step of constructing the ERD. Finally, the entity relationship diagram is used to connect the logical structure of the database to the user. In particular, the entity relationship diagram effectively communicates the logic of the database to the user. Here are mainly three components of ER diagram. Okay. Three main components of entity relationship diagram, which is entity, attribute, and relationship. These are three main components of entity relationship diagram. Now, first is the entity. The entity we can say a real world object, which can be any person, any organization, any animate or inanimate, whatever it may be. It related to real world object. It can be only identifiable thing in this entity relationship diagram. Okay, an entity is denoted as a rectangle. For example, in a school database, students, teachers, and classes. and courses offered can be treated as a entity. All these entities have some attributes or properties that give them their identity. Every entities have different kinds of properties, which is attributes that give them to the identity. It's a entity set. The entity is a different portion and entity set is another. Entity set can be related to the multiple number of related entities. Okay, the collection of related entities called as a entity set. Entity set may include entity with attributes sharing similar values. For example, a student set is an entity set, may contain all the students of a school. Likewise, a teacher set may include all the teachers of the school from the faculty. Okay, so here employee is an entity and department is also another entity. Employee can be person, department can be organization. A set of persons, set of organization can be called as an entity set. These two entities is having a particular relation which is called as working relation. What working relation? Employee works for department. Next is a attribute. The properties of the entities can be called as a attributes. And all the attributes have their particular values. For example, if a student entity, we consider the student entity can have the student identity number, student class, student name, student age, whatever students detailed information can be taken from these attributes. There exists a domain or range of values that can be assigned to attributes. For example, a student name cannot be a numeric value. It has to be alphabetic. A student age cannot be negative, etc. etc. Here, a student is a entity and name, address, age, ID number, these all are the attributes. So again, we can divide or we are having different 4 types of attributes here. First is key attribute, second is composite attribute, third is single valued, multi-valued and derived attribute. Sorry, 5 types of attributes. Okay. Number 1, key attribute. Key is an attribute or a collection of attributes that uniquely identifies an entity among the entity set. For example, roll number. Roll number makes a student identified. We can identify a particular student by their roll number. But number of students or 2 or more than 2 students can have same name. But 2 or more than 2 students cannot share same roll number. Roll number is a different for different students. Okay. And name, age, address are the normal attributes. Age can be derived and address is a composite. We will see next. So here in key attributes, there are different again 3 kinds of keys. One is a super key, candidate key and primary key. Super key is a set of attributes that collectively identifies an entity in a entity set. It collectively identifies in a entity set. Okay. Candidate key. A minimal super key is known as candidate key. An entity set may have more than one candidate key. A particular entity set can have more than one candidate key. And third one is a primary key. Primary key is one of the candidate key chosen by database designer to uniquely identify the entity set. These keys are used for the entity set. So first one is a what we learned key attribute. Second one is a composite attribute. Composite attribute is an attribute that is combination of other attributes called as a composite attribute. For example, as we said before, a student's address. Okay, address can have multiple again different attributes. Okay, a student is an entity, address is an attribute, it is a composite attribute. So it having again a combination of other attributes. What is that? Pin code, state, country, likewise district, taluka, place, street, street name, street number, etc. etc. can be a composition for address attribute. So address can be called as a composite attribute. Next, third is single valued attribute. The single valued attribute is uniquely identified for that particular entity, which is having a particular single value, which cannot be a copied or cannot be used for different entity. So Aadhaar card number, identity number, mobile number, Aadhaar card number, identity number can be a single valued attribute. Mobile number can be multi-valued because a person can have more than one mobile number. Okay. Fourth one is multi-valued attribute. If an attribute can have more than one value, it is known as multi-valued attribute. Like I said, mobile, email address, or sometimes addresses. A particular person can have more than one address also, more than one email ID also, more than one phone numbers also. Okay. So this is the multi-valued attribute. Now, student is an entity which is having a roll number, name, date of birth. Date of birth, we can say date of birth is a derived attribute. How derived attribute? We derive, age is a derived attribute. How it is derived? It is derived from the date of birth of a particular entity, a particular person. Age cannot be denoted. It is derived from the date of birth. And phone number is multi-valued attributes. It denoted by double ellipse. Okay. And address is composite attributes, which is having different again attributes. Okay, third one. Now we have done with entities. Sorry. Entities, attributes, and now relationship. Relationship. The association among entities is known as relationship. Whatever two entities are sharing is called as a relationship. Two entities share a particular particular thing, which is relationship, and which is denoted by a diamond shape. That like teacher teaches student. And before we learned here, employee works for department. Working is a relationship between employee and department. Okay. So teacher and student, here teacher and student is an entity and teaching is a relationship between these two entities. So we are having again three types of relationship sets. Means we can say degrees of relationship sets. Which kind of relationship is which kind of relationship they share, by which we can describe them as a unary, binary, or ternary relationship. Okay. A set of relationship of a similar type is known as relationship set. Like entities, a relationship too can have multiple attributes. These attributes are called as a descriptive attributes. Whatever attributes we are using for entities can be have these kind of attributes to the relationship. Okay. So according to the relationship, according to the number of participating entities, there are multiple degrees. Okay. So three most common relationships in the ER data model. Okay. First is unary, that is degree 1. Second is binary, that is degree 2. And third is ternary, that is degree 3. The first is unary relationship. This is also called as recursive relationship. It is a relationship between the instances of one entity type. For example, one person is married to only one person. This is unary relationship. Person married to person. Binary relationship. This happens between two different types of entities, like teacher teaches subjects. And next one is a ternary relationship. Ternary relationship may have many to many relations. Means many entities can be related to many entities. Likewise, a single student may have a single subject and a single teacher, or many students may have many subjects or a subject, many teacher or a teacher. Okay, a single teacher may have all students, but a single teacher may have only one subject, or sometimes it can be all subjects or many subjects also. So like many to many relationship is called as a ternary relationship, which is having three participants, more than one participant or more than two participants. Two participants, instead we say entities. More than one or two entities is having a particular relationship is called as a ternary relationship. Okay, thank you for today. Whatever you have query, you can ask me.